Hi, welcome to another class with Fast Academy. Today what we're going to do is study the first chapter from ninth physics, which is motion. Something that we all need to understand is this is one chapter that is going to hold basics to most of what you're going to do for the rest of the next 3 years in physics. And understanding motion across one dimension is also going to set the basis for you to understand motion across 2 dimensions and probably 3 dimensions as you go ahead studying physics through your life. The first part of today's chapter is mostly going to focus on major important definitions, something that is going to help you understand this chapter, something that's going to help you appreciate this chapter in a lot more greater depth. The first definition that we're going to learn today is a concept called as rest. Now, this is a common term that you would have used across several times during your course of life. They said, he's feeling tired, he's probably wanting to take some rest. Or you might just want to say that the batsman just finished playing cricket and decided to rest for a while. But when it comes to physics, it's important that you you give the right definition based on certain keywords. So let me take a very simple example. Assume I have this little box on a table, and so let me also have another source. Maybe we have a tree next to it, right? So I have a box here and I have a tree here, and let us try and understand the definition of rest based on the position of the tree and the position of the box. Let us assume that I place this box next to the tree at about 8:05 in the morning, and I measure the distance between the tree and the box, and I noticed that the distance between the tree and the box was approximately 10 meters. This was at around 8:05 in the morning. Now, let us assume that I come back, say at about 10 o'clock, roughly 2 hours later, and I try and determine the distance between the tree and the box. I would like to believe that the tree hasn't moved from its position, nor has the box moved from the position, so the distance continues to be 10 meters itself. That is when I say that this box is in a state of rest with respect to the tree. Now, using the word with respect to becomes a very important word, because you are only going to measure the position of a body with respect to another. Therefore, the definition of rest, and if you have a book and a pen next to you, you can just make a note of it. The definition of rest tells you that if the position of a body, I'm referring to this body, if the position of this body does not change with respect to time, with respect to another body, then this body is said to be in a state of rest. So you simply say a body is in a state of rest if its position with respect to its immediate surroundings does not change. Alright. Now that we understand what rest is, let us try and understand the next definition, which is motion. It's something similar to what we just dealt with. When you say the body is in a state of rest, when its distance or position with respect to its immediate surroundings does not change, then you say a body is said to be in a state of motion if its position with respect to its immediate surroundings tend to change. For example, I have a tree, I have a person, and I'm referring to this person and I'm taking him as my subject right now. So assume he's running a marathon. His distance from the tree is approximately 30 meters, and assume he's running in this direction. Let me measure his distance, say after an hour, and I like to assume that he's somewhere here, at a distance of 100 meters after an hour. So that's where the boy is going to be. So something that we've noticed is that his position with respect to the tree has changed, and hence I would like to say that he's in a state of motion. So we say a body is said to be in a state of motion if its position, and when I talk about it, I'm referring to the subject, which is the person here. A body is said to be in a state of motion if the position with respect to its immediate surroundings changes with respect to time. Now that we have understood the meaning of rest and motion, this is going to help us understand the rest of the chapter. Let us go into the next definition. The next definition we're going to learn is something called as a scalar quantity. Now, when we refer to something called as a scalar quantity, You need to understand that we have to use two important keywords when it comes to this and the definition that we're going to do next. One is called as magnitude, and the other is called as direction. Now let us try and understand what these definitions really mean. When we talk about the word magnitude, we are referring to something called as the value. And when we're talking about the direction, we're trying to find out how the body is moving. Is it moving to the right? Or is it moving to the left? Is it moving down? Is it moving up? Or is it moving in some other direction? So putting this into one definition, we'll be able to define a scalar quantity as a physical quantity that has only magnitude and no direction. Let us take a very simple example. When I talk about a term called as mass, and when I say the mass of a boy is 30 kg, you see this number 30 here? 30 becomes the magnitude because that is the value. And I will never ever describe the mass of a boy to be 30 kg in the right direction. That doesn't make sense at all. I'll just have to tell you that the mass of a boy is 30 kg, and since I'm referring only to the magnitude, which is 30 kg, I'm not referring to the direction at all. So if you notice there is no direction at all, then mass becomes a scalar quantity. Now let us try and understand what vector quantities are, which is the next definition. I'm going to put magnitude and direction again. Now, since I started with the term physical quantity for a scalar, I shall also start with a physical quantity for a vector. When we talk about a physical quantity for a vector is a physical quantity that has both magnitude as well as direction. Let us try and understand a little bit more about it. I'm going to take a concept called as distance and displacement to help you understand this concept. Now let us take a simple scenario where your house is located here, and let us assume that this is your school where you wish to go. Let us assume that there are two people who set out on their journeys, the person who's blue and the person who's red. Now, while both of them are planning to go to school, both of them choose to travel to school in very different ways. Blue first wants to travel to a candy shop, and then later travel to a temple, and then go to school. So this is how the first person is planning to travel, whereas the second person likes to go along a straight path and reach a school. Now there is a fundamental difference in how both the students have entered school. The blue student has taken a longer path because he's traveled various other places, intermediate places in between to reach school, whereas the red person has directly entered school through the shortest path. And if you understand, the shortest path is always along one direction. The shortest path happens to be only in one direction. Since I've used the word direction there, the path he's taken becomes a vector quantity. Whereas if you look at how the other person has traveled, he's first traveled along a particular path to reach his candy shop, and then he goes through another route to reach the temple, and then he takes another route to reach the school. So there was never a defined direction in any case. He traveled through various places before he hit school, so he never took a definite path to school. What if he decided to go to another intermediate point here? That was also possible. And then what if he had forgotten to pick up a candy? Maybe help him go back there. And then if he had decided to go back school, this again becomes a case where he has not followed a definite path. He's followed different paths altogether to reach his ultimate destination, and therefore just becomes a scalar quantity. So based on this, we'll be able to define two very important terms. The first point is called as distance, and distance is the black path that he travels. This is the actual path that the person has taken to travel from his source, which was his house, to his final destination, which was his school. Whereas displacement is the shortest path the student has taken in a definite direction. And if he chooses to go in any other path, it's always going to be the longest path. The shortest path is possible only when he goes only in that one specific direction. And since the specific direction word comes in the definition, it becomes a vector quantity. And hence, displacement, which is your shortest path, becomes a vector quantity. And since in distance, you can go in any possible route, it becomes a scalar quantity. Right? So let us take a couple of examples to help ourselves understand this a little more in depth. Let us take a circle. And let us assume that this is a circular field where there are two people. Again, there's one in blue and there's one more person in red who are trying to go across, who are planning to go around the circle. Let us assume that the person in red finishes one entire round and then gets back to the same position. Let us understand this scenario a little bit in detail. Let us assume he started from point A. So he started from point A, which is your source, and he came back to point A, which is also your destination, which means he's literally traveled from point A to point A, and the shortest distance between point A and point A is 0 meters. Therefore, since we are referring to displacement to be the shortest path between the source and destination for the person A is going to be 0 meters, indicating that he has covered zero displacement, although he has traveled one entire round around the field. However, he's definitely covered some distance when he's gone across, and since he's traveled around the boundary, he is going to cover a total distance of the circumference, and the circumference of a circle is given by 2 pi r units. So while he's actually traveled 2 pi r units, 2 pi r units becomes something called as the distance, and 0 meters becomes your displacement. Therefore, it is very, very essential for us to understand the meaning of distance and the meaning of displacement. Displacement is always along a suitable fixed direction, and hence displacement becomes a vector quantity while distance becomes a scalar quantity. I hope you enjoyed this class. We will meet in the next class again, where you will be learning more definitions.